Morning. Welcome to my office. This is where a lot of problem solving, brainstorming, our 3D modeling, which is a big part of what we do before we actually start building things. This is where it happens. And I'm not the only one that does it. There's two other computer setups in this office. But this is uh, this is where some of the magic happens. So our 3D modeling program is Fusion 360, part of the Autodesk suite of softwares. And that allows us to draw things in 3 dimensions and give them measurements, constrain them, meaning like tie them into certain geometry, give them angles, radiuses, and things like that, so that when we actually go and build it in our shop, we know based on the measurements that we took out in the field that it's going to fit where it needs to go. So this is our current project that we're working on right now, and I'll give you guys a much more close-up view of the Snowcat. Oh yeah, as you can see, mouse, other mouse, and keyboard. So this mouse by 3D Connection is called a space mouse. So that allows me to just spin this, and I can spin whatever 3D model I'm looking at. Go up and down, can zoom in, focus on a point. It's like TIG welding, except you don't use your foot this time. You got to use both sets of hands, come over to your number pad, put in measurements, and it, just like anything else, takes time to get used to. So this is what our 3D model of the Snowcat is going to look like. This is the existing tank tracks that are already in place, the undercarriage, the steering cabinet, and this frame back here is pretty much all that we're building. Oh, and then there's a snowboard and ski rack on the back. So, as you can see, when I walked through it earlier, seat pan here, jump seat here, 3 seats back here, speaker system up here, more cubbies, heater controller up here, little storage unit on the top, as well as the rack that you'll see me welding on later. So this is just one of the things in Fusion that we work on, but I'll walk through some other cool little things about the program and how it helps us do our job more efficiently. Sorry if there's a little bit of background noise. Both of our heaters are running and our big roll-up doors are rattling. It's currently -1 degrees with a high of 2 degrees and a low of -16 with wind chill. So I'm going to be bundled up, and today we're going to be going through AC welding, or alternating current welding. Now, the reason I'm talking about this is you'll see clips later of me welding on aluminum and the sound that comes with it. It's much different than DC positive or DC negative welding, which we use for mild steel. Now, AC welding, alternating current. So the normal flow of electricity is its current, and you can change that with our machines, our TIG welders, to the electrode positive or the electrode being negative. Now, the electrode is that piece of tungsten that we talked about earlier. It's the metal with the highest melting point that we know of, and the shape of it when TIG welding is much different, which we'll go over later.
On the left, we have the tungsten shape of what we are looking for when it comes to mild steel welding, whereas on the far right, that ball is what we look for when we are going to do aluminum welding, so the cleaning action has more surface to cover.
So, why do we use alternating current welding? Well, for aluminum and I believe magnesium, when welding, the aluminum specifically, I don't know about magnesium, but when molten aluminum interacts with oxygen or the environment around it, it creates aluminum oxide, which has a melting point of, I believe, 3,600 degrees Fahrenheit. And pure aluminum melts at about 1,200 degrees Fahrenheit. So when we're doing this weld, we want pure aluminum to be what joins our two pieces of metal together. Aluminum oxide can kind of make it look a little dirty and not be as strong. So how do we get rid of that aluminum oxide? That's what the electrode positive part of this one alternating current cycle does. It burns off all those impurities and then allows the electrode negative part of the cycle to create that penetration with the pure aluminum. So our machines allow us to set the balance. This would be called the cleaning percentage of the welding process, or the one alternating current cycle. So 50% electrode positive would mean the electrode positive percentage for one cycle is the same as the electrode negative. Now, for material with a lot heavier scale or that's much dirtier, you would kick up that cleaning percentage so that you get a good clean weld with proper aluminum rather than all that aluminum oxide, which could create flaws and, like we said, cracking and stress, which we don't want. Ooh, this is not a pleasant angle, actually. Oh, this is actually cold. I couldn't see the puddle that whole time. Nice. How did it turn out, actually? It could have been hotter. Now, folks, that's what I call functional mobility. So I'm going to be using our finger brake to put a bend in this piece of aluminum. You can see my Sharpie marks, and I'm going to line those up with the clamping teeth, which you'll see me move down, get a little closer, and then finally clamp down on the piece of aluminum. A finger brake is just a manual way to put bends in thin enough sheets of sheet metal. This is already pushing the limits for this machine or this tool. So that's my little leverage extender. And then because this is aluminum, it bends rather easily. So we'll go just past 90 degrees because that's what I'm looking for, and just past because almost all metals are going to have a little spring back factor. So you got to go a little bit past, you'll eventually get what you're looking for. And then voila, we have the final shape.
So these are going to be some last minute roof rack tabs that'll be used to strap down whatever cargo is going up in that roof rack. Now these parts just came off of our water jet, and the reason I'm using the grinder on them right here is to soften all these edges. If I weren't to do this, the razor sharp edges that these have coming off of our water jet would just tear the strap right in half, and then that cargo that's being stored up top would fall right off as they head up the mountain.